All right, perfect. So recording has started. All right. And again, in spite that only 11 students out of 34, 44 are attending the class, I will not postpone the class. I will continue, but it's good opportunity to us to go through the previous lecture once again. So I will start. We had two sets of slides. We talked about, or we started talking about the classes. So I'll go through them very fast just to remind you of the main topics of the classes. Then I will continue with the rest of the lecture. So as we said, the classes and on object-oriented, one of the important thing is or are the classes. And we say that every object, or in programming, we look to everything as an object, like the student is an object. Okay, the car is an object, the computer, the software, the program itself, it's an object. The variables, whatever you think about, all these are known as objects. All right. Every one of these objects can be represented by a class. So if I take the student, I represent the student as a class. I will write here the keyword class. Then I'll give a meaningful name for the class, like student. All right. Then I will start code block. Please remember this semicolon at the end. Usually we forget it. Okay. Here we have two different or two kinds of things that we need to focus on, additional to the class name and the attributes and the method or the methods. All right, the attributes like any feature of the class of that object, like student has integer ID. Of course, it's not necessary to be integer, but in our case, and let's if you consider our college, all your IDs are number, like 2022 16123. But it sometimes contains letters, so you have to make it string. So string name. All right. String specialization, etc. So here the attributes are the features of the objects. The methods here are functions, or sometimes they are known as member functions, that the object or that can be applied to the specific objects. Like in the case of the student, what are the functions? You can find millions of functions, but let's take some examples. For example, calculate GPA. Okay. For example, another method, let's say, calculate attendance. Okay, and so on. So all these are methods or member functions of the class student. So object and classes, as we said, the class is a programming structure that can be used to define an object. It consists of class, the keyword, then the name, okay, the attributes, feature of the objects, and methods and member functions of the class, and operations or activities that can be done. Example, student, as we say. Another example is the car. For example, if you have the car, if you represent the car as an object, I will ask you two questions. What are the attributes? And what are the methods? From now on, I will use only the method to refer to the member functions. The attribute of any car are model, year of manufacture, model year or yeah, manufacturing year, fuel, number of doors, and so on. All right. The methods. What are the methods that the car or the activities as we said here, the methods are not only things that can be done on that specific object. It's also operations, activities that can be done. All right. So the methods, for example, fuel consumption, calculate fuel consumption, right? Any other method like calculate price, etc. So for any object, if you want to describe the object in a class, you have to think of two main things, the attributes and the methods. Access specifier, this is very important, and we will take a lot of examples to explain this because of its importance. So here we are talking about access specifier, how to access, how one class can access how any function or from outside the class can access the attributes. And so suppose that I have here a class, all right, and in that class I have, we said, attributes and functions or methods. Here, in order to access them from outside the class, it's just like a building block, all right? So if I want to access these things, I have three options to access them, or according to the access mode. If they are private, then I will never be accessed. For example, here, if I want to access them from the main function, integer main, okay, if they are private, I will not be able to access them and they will get error. And we showed this and we will show it again. All right. If they are private, as we said, we have three P's. All right. Public, private, protected. So the first case is the private. By default, any attribute, if you don't write, if you don't give the specification or the access type, then it will be private. So for private, it's not possible to access them at all. Then if I cannot access the private, then why should I have them if they are inside the class only? These can be accessed using public methods from the same class, okay, or methods or attributes also from public methods or attributes. Although they are public, but I have to define or declare some public members which can access the, so in order to the main function to access, or not only the main function, I mean anything from outside the class, to access the private attributes, they need to go to the public, and the public will access them. They will get the result and send them back to the main. All right. This is very, very important to know. If they are private, you, or not you, I mean any program, any code from outside the class cannot access these private. How to access them? We need to generate public members that can access this private and send them back to the whenever they need it. Not necessarily to be from main. I can call them from another class. All right. This is the private. The public, as we said, they are directly accessible. You can access them directly. Protected. This type, of course, the main two types are the public and private, but this type, that means if I have a class, this will be explained in inheritance. All right. We talked a little bit about inheritance, but we'll talk more. Protected can be accessed only by the class itself, okay, or from the derived class. All right. And inheritance, we'll talk about them. So, for example, take this example. Class object, I defined a class object, okay? I declared public. By the way, for simplicity, at the beginning we'll declare everything as public. Later we will do them in different way. So public integer x. As we said, the declaration of the class should start with the class, then name, then the code, and of course don't forget the semicolon. All right. So I have public integer x, void set x, okay, member function or a method, and x equals to n. This is if I want to set the value or change the value. Later we call them mutators. All right, I use this function. Okay, and of course return. This is accessor. Return x to read the value of x. Now, in this case, by the way, if x is private, then I have to declare this as public. Okay, in order to access the value of x. All right, there's another example. Now, object here I declared as private. All right, so x cannot be accessed. I cannot, when I go to the main function and declare an instance of the object, let's say a, I can write or use a dot set x of 5. This is correct. I can say return. Okay, I can say a or b, integer b equals a dot return x. Okay, this is correct, but I cannot say a dot x. Why? Because x is private. Okay, this is not allowed because x is private. Okay, so here if you can see public, I use the keyword public so that set x is a public and return x is public. So in the main function, when I declared an object b dot set x, this is correct. Integer y equal b dot return x, this is correct, but I cannot write here b dot x. It's not allowed. Why? Because x is private, while set x and return x are public. All right, let's see what else. Now public. This is an example, another example, and of course we've written this example and we executed just again to repeat it. Here I'm going to declare a class. The name is point, and of course, as you know, for any point you want x, two-dimensional point, x and y. Let's say this point 5, 7. All right. That means this is the value of x and this is the value of y. So the point here can be declared by two attributes, right? X value and y value. So the point here, as I told you, here we are talking about public. Okay, so I can access the value x and y directly. So this is the class point public x and y. Here I can access them, as I said, directly. So when I declare a point, an instance from this object and name it as point, okay, I can put p1.x equal 5, p1.y equal 7. That means I could access x and y. Why? Again, I'm repeating this again and again because they are public. Here. Okay. So, of course, I can write them now. I can use them as regular variables, so px, py, and that's it. Now let's see private. If I change this public keyword and make it private, or even if I don't write it, again, if you don't write this private, it means they are private. Okay, x, y. And use the same code and try to access the points, then what will I get here? I'll get this. Let's read the errors. In function integer main, First error, integer point x is private. It's telling me that it's private. You cannot access them. Y is private. You cannot access. That's why I'm telling you always, when you get error, try to read the errors. The error is not telling you, not only to tell you that you cannot execute the program. No, they give you some suggestions, or they tell you what the error is. So here, also x is private and y is private. Then now again, I'll go back to my previous question. If they are private and I cannot access them from here, then what's the use of having them? All right, what's the use of having them? Of course, they are private, but here I can declare public or protected later when we talk public members. And when I say members, I mean either attributes or methods. All right. In this case, I will use these public things, okay, to access the private variables or private members. All right. So in this case, I will define. See, nothing has been changed. Here I have private x and y. I defined a public, okay, set coordinate, public method. I'll call it set coordinate of integer x coordinate and integer y coordinates. In this case, see, these are public. I can access these things. So from the main function, I can, from anywhere outside the class, I can access these variables. All right, but these variables can access the private members of that class. That means if I want to access this, then of course I have to access through public members. The other one is print coordinates. Of course, this will print the values. Now let's see. Outside the class, integer point p1. All right, p1 set coordinate. I passed these two arguments to the set coordinate. I can access set coordinate. Why I can access set coordinate? Because it's public. I will not get error. And these coordinates, or this method, will access the private values. All right, for private members. Okay. Then in this case, when I want to access them, as I told you in the previously, I have here private members. I have public members, and I have, these are in one class. Okay, so if I want to access the private members here outside, maybe a class, maybe a main function or anything. So in order to access them, I'll go to the public, and the public will access them. All right, I cannot access them directly. I can access them through the public members. Protected, as we said, can be accessed by class, the class itself, and the derived class when inherited features from the superclass. Now, this is also a very important thing we talked about, which is the constructor. For any class, okay, for any class, there should be a constructor. Not should be, of course, you can write class without constructor, but as a programmer, you need to think about the constructor. The feature of the constructor, if you can see here, I have class point, okay? And I have the same name, public method. And again, remember, it has to be public. I'm sorry, guys. Public, which is a constructor. Usually, we use the constructor to initialize for initialization. All right. So in this case, the constructor point, integer x1, integer y1, that one will initialize the value of x and y. Okay. We talked about this, nested classes, accessor mutator. See, again, I will repeat it very fast, although I'm not repeating things fast. I'm just re-explaining everything. All right. So here, if you have, for example, the private variable n, as we said, you cannot access it directly. That's why we use something called accessor mutator. The accessor can read the value and send it back. For example, let's say read or get number, read the private members or access the private members and send them back outside the class. The mutator can set the value, okay, for of the private members. Okay, so this is, check this class. I have a class called NUM, numbers, standing for number. All right, and I have private members, which is N. As we said, if I want to access this from outside, I will get error. All right, so what I'll do, I have two kinds of functions which are called accessor and mutator. So if I want to read the value, I'll go to the accessor. Of course, you can give it any name. I gave it get number. All right, return n. So if I want to read the value, I'll go to the accessor, asking about the value. The accessor will access the value and will not get back to the function. It will go here and send the value back. All right. Now the mutator, if I want to set a value, then what I'll do, I'll send the value like I send 5, okay, and the mutator will change the value of n to be 5. Okay, that's why we call them accessor and mutator. Defining member function outside the class. See, sometimes you need only to declare things inside the class. So it's very easy. If you can see here, I define the functions inside the class because the class starts here and ends here, right? So everything inside the class. Sometimes you need to define the function in the class and put the functionality outside the class. So it's very easy. Here in this class, if you can see, I just declared the function integer get number, void set number of constant integer number, all right, and private n. So what these functions will do, so now they are not defined. If you want to write them outside the class, then you have only to mention that they belong to this class using the class name, in this case NUM, and adding 2 colons, all right, like this, and the name of the function. That the compiler will understand that you are writing a function which is a member of the NUM. The same thing here, all right? I just write NUM colons and that's it, all right? We finished this part. And the second lecture also was covered. Okay, and I will go through it once again and very fast. Just let's see how many students we have in the class now. 32. All right. Okay. Or not today. We will repeat again the inheritance. Inheritance means if I have a class, okay, with some features like person. Okay, it has some features like name, birth date, and other features. Then when I come to declare student, all right, I will find that name and birth date and some other features are redundant, are repeated. So what I'll do here, I will inherit these things from the class person. We call this superclass. or parent class or upper class, several naming, and we call this as subclass and child class. Let's see. So inheritance, when derive a subclass from an original class, the derived class, subclass, or child class, all these are the same meaning. All right, will inherit all the attributes and methods from the original class, which is superclass or parent class. Let's see. Here we talked about some explanation. I think the next slides can explain this also. Why inheritance? Why we need to use inheritance? Why we need to invent something new, as we don't have enough headache to talk about in programming? Actually, here, consider a group of employees, just a scenario, okay? Let's consider that we have in one of the organizations, we are a group of employees. We need to create a class for a programmer, an administrator, an HR specialist, an accountant, any other jobs, okay? And others, of course. The methods, assume that the methods are calculate salary, okay? And calculate the leaves and some other features. Of course, here, all of them have names, right? All of them have IDs. All of them have what else? Birth date. Okay, so there are a lot of things in common between all these classes. So to avoid redundancy, repeating the same thing once again, again and again, what I'll do, I'll collect all the common things in one class and call it employee, which includes all the basic and common features. We call features or attributes and methods. All right, and remove them from the individual class. So when I define programmer here, okay, I will inherit all these things, okay, or the programmer itself. I will not inherit anything. I mean, the class programmer will inherit all these things from the superclass. In addition, it can add more like programming language, okay, like computer type, any other thing that is dedicated to programmer. Okay, then when I define another class, which is here, what other things? Administrator. Okay, it will inherit everything. In addition, since he or she is an administrator, that means he is running or she is running a department. So department to run. Okay, responsibilities. HR also. What part? What is the difference between these employees can be included in a specific or in the subclasses. All right. So if you can see here, let's assume that we have a programmer class, we have attributes name, ID, field of programming, and methods calculate salary. The HR attributes name, ID, responsibilities here is different, all right, and calculate salary. Of course, this is just an example. Remember, this is not an ideal case because you will find a lot of attributes, a lot of functions that were not mentioned here. So here the administrator also attributes name, ID, department to run is different, and calculate salary. So instead of writing here 3 different classes, this is a class 1, class 2, class 3, and of course I can have more classes. Okay, here I can Write 3 classes, of course. Instead of writing 3 classes, I will write 4 classes. Okay, but in this case, I will take all the common things, like in this case, these things, and put them in one superclass and inherit these features or attributes or methods from the class. So in this case, if we could take the common attributes and methods and put them in one class, superclass, and other classes can inherit these from it, then it will. What is the advantages of this? Make program easier to understand and, of course, debug. Okay, and control, etc. Reduce redundancy. If you can see here, the name, the ID, the salary, etc. All of these are redundant in every class. So the possibility of having errors will be higher. Okay, so one of the things, important things, is to reduce redundancy. Reduce any chance of error. When you write one line or 2 line of code, better than writing 6 or 7 or 8 lines of code. In this case, the error will be less. So this is the suggestions. I will create a class which is called superclass. Call it personnel. Okay. The attributes of this class are names and ID. The methods are calculate salary. All right. And I'll create another 2 subclasses. These are subclasses. Okay, subclass 1, programmer. See, the programmer will inherit everything, will take everything from the personnel, but it can add another part, which is field of programming. The HR also, the administrator will inherit everything. So this is the idea of inheritance and the importance of inheritance. An example, here I have class A, integer X, Y, Z, class B, integer X, Y, W, class C, integer X, Y, and V. All right, that's perfect. I don't have any issue with this, but since these are common among all the classes, then think of creating a superclass, okay, which I'll name it as S, okay, includes X and Y. Now, class A, when I write this A and colon S, it means everything in S will be taken by A. All right, that means X, Y, etc. Here we will see that there is a specific and important thing about the access specifiers or access specifier. We say protected, right? And I told you protected will be discussed in inheritance. Public will be public. Protected will be accessed by A. All right, A can access protected, but main function cannot access protected things. All right, here also I have B inherits things from S, so everything S has will give it to B, in addition to the other attributes. Class C also will inherit S, so everything in S will be part of C again. So if you can see, of course, here the code has become larger, right? But actually, now if I had methods here, if I want to change the method, let's say if I have a specific method, if I want to change the method, in this case, I have to go to A and change the method, then update the method in B and in C. While here I can update it in S and it will be reflected to all other classes. How inheritance work? Now, if you have here class S, okay, I have public x, y, and I have public void. No need to write it again here because public, unless you change it, it will be public. And I have public void print, C out x and y. For example, this class A, public here. Also, this will be discussed thoroughly. Now, basically considered as public, all right? Because I don't want to, we want to show that some code that can be executed now. Later, I'll tell you what are other kinds. What was supposed to be in today's lecture, but since we repeated some of the code, some of the slides, I think we will not be able to discuss today. Next lecture we'll discuss it. So consider as public always now. So class A, public S, that means it will inherit everything from S. See if you can see here, public in class A, public integer Z. Actually, that means here, the class A, if I write class A, okay, that means in class A I have public integer X and Y, and I have void print, okay, and I have integer Z. Why? Because I inherit the class inherited these from the superclass. That's why I don't need to write them. They are inherited. All right? They were inherited from the superclass. So if you can see here, integer main A, I declare A, and as I told you, A dot to access the members, then I have only one member here. So I can write A dot Z only. No, I also inherited X, Y, and the print. Okay, so when I declare A, I can access A dot Z equal 5, A1 dot X. If you can see now, X is not a member of class A, but A inherited it from S. A dot Y, A1 dot print. So I can access everything here because A has inherited everything from S. Let's see this example, this point. Okay, this is the if you remember, we talked about the point is the same point, get X, get Y, set X, etc. Here I can we are writing a class circle which inherits everything. Why? Because point has X, Y, right? This is the point. While the circle has X, Y, and radius. So why we need, or do we need to define a new class and define everything while I can inherit this from the point? So here, public double radius, and here the constructor is very important. In circle constructor, as we said, I need X, integer X, I need integer Y, and I need integer or double. I prefer to have it double because we can do some calculations. Double R, all right? You don't need to create a new constructor for X, Y. Why? Because they are already defined in the point. So I put colon, then point. That means I will send X to X and Y to the point Y, and only R needs to be declared. Now I can add another thing or another method, which is, for example, find area. This is the code I shared with you, just asked you before to implement it. Okay. Now, using this for an inheritance, of course, circle, if you could see that this means that the class circle inherits all the features and methods of the class point. The class circle could have more attributes and methods other than those available in point, and circle is known as child class or subclass, while point is known as parent class or superclass. The constructor, as explained to you, Here integer x, integer y, double R, colon, point, that means x and y will be passed to the point constructor. Of course, subclass can have more functions. We define the new function, which is find the area as a member function. Okay. Now inheritance modes. We will continue, or will continue this in next lecture. We'll talk about the inheritance mode. We have several inheritance mode and types. All right. If you have any questions, please feel free to ask. I'll stop recording now.